Right, this is going to be the last video for Chapter 1. We're going to start Section 1.6, Other Types of Equations. And what we're going to pick up in this section, we're going to be able to solve polynomial equations of degree 3 or greater, solve equations involving radicals, solve equations involving fractions and absolute values, and we'll use polynomials and equations involving radicals to model and solve, real-life type problems. So here in example 1, we're going to look at a polynomial equation, and we're going to solve this by factoring. Now, when you look at this problem right from the get-go, what you might think right off the bat is I have x to the 4th on the left, x squared on the right, so I can divide each side by x squared to get that to simplify. And that would be the wrong turn to take. When we're solving equations, we could divide through by the number. We could divide through by 3 and have no problems. But when you divide by a variable quantity, you can create you could create an extraneous solution, a solution that's not going to work in the real problem, the original problem. So to start this one, I'm going to get everything on one side and set it equal to 0. So I'm going to have my 3x to the 4th, and I'm going to subtract 48x squared from each side. And now it's equal to 0. Because remember, when we solve these equations, we usually set them equal to 0, factor them, and set each factor to 0. Let's see, now I could divide through by a 3, or I could just say I factor out a 3x squared, and that's going to leave me an x squared minus 16, and that's equal to 0. And I see my x squared minus 16 is a difference of squares. So that's going to be a sum of the difference, x minus 4 and x plus 4, and all three of these factors multiply to 0. So I can set each factor independently equal to 0. When I set 3x squared equal to 0, I get x equals 0. When I set x minus 4 equal to 0, I add 4 to both sides and get x is positive 4. And when I set x plus 4 equal to 0, I subtract 4 from each side and get x is negative 4. So there are three solutions. And let's get in the habit. We might as well even check these back in the original equation. So if I take my original equation, 3x to the 4th minus 48x squared equals 0. If I plug in the 0, or my original equation was 3x to the 4th equals 48x squared. I guess it doesn't matter either way. But if I plug in 0 for x, I get 0 to the 4th times 3 equals 0 squared times 48. 0 equals 0. That does check out. Here, if I plug in the positive 4, I'm going to have 3 times 4 to the 4th power equals 48 times 4 squared. And if I divide through by 3 right here, I would get 4 to the 4th equals 16 times 4 squared. And I can rewrite that 16 as 4 squared times this other 4 squared. 4 squared times itself is 4 to the 4th. So positive 4 also checked out. And since if I would plug in the negative 4, since this is an even exponent, and this is an even exponent, it doesn't matter if I plug in the 4 or the negative 4, these answers are going to turn out to be exactly the same. So all solutions did check. I wasn't too worried about it there because we did not divide by a variable quantity. And I usually spend a little more time on this stuff in the videos than I do in the classroom because I'm always watching the clock in the classroom. Let's start right off the bat and divide by 0, or divide by x squared and 3 and see what happens. If I start off dividing by 3, I get x to the 4th equals 16x squared. And if I divide here by x squared, which you're not supposed to do, divide by that variable quantity, I get 16 equals x squared. Aha! And then I have a square. I can square root both sides. And I'll have x equals plus or minus 4. When I divided through right here by x squared, I lost a viable solution, a real solution to this equation. We lost the solution x is equal to 0 when we did that. Remember when we did stuff before when we were working with fractions, and we're going to do that later in this section, when we were working with fractions with variable denominators, if we multiplied through by a variable quantity, we could create an extraneous solution. Here we are doing the opposite. We're eliminating a good solution that we would have found otherwise. Example 2, solve a polynomial equation by factoring. And I look at this and I see x to the third minus 3x squared plus 3x minus 9 equals 0. How are we going to factor that? It has 4 terms. Highest power is x to the third. That should be making you think, setting off some bells if we factor by grouping. So out of the first group of parentheses, I can factor out an x squared, and that'll leave an x minus 3. And here I have plus. I can factor a 3 out of the second term, and I'm left with x minus 3, and that's equal to 0. And so I have these terms the same, x minus 3 and x minus 3. I sort of factor those out of this bracket, and I have an x minus 3 outside the bracket. What's left inside is x squared plus 3. And that is equal to 0. Now we have two things multiplied equal to 0, so the zero product property says I can set each independently to 0. So x minus 3 equals 0 means x is equal to 3. And my other one, if x squared plus 3 is equal to 0, we can subtract 3 from both sides. X squared equals negative 3. And now that I can have my squared term isolated, I can extract the square roots, and I'll get x equals plus or minus the square root of negative 3. Remember, we can deal with those negatives now, bring that out as the imaginary component, and we have our root 3. So two answers, x equals 3, or x equals positive I root 3, or x equals negative I root 3. Now in example 3, it says solving an equation of a quadratic type. Remember, a quadratic, our most common type, was, we'd have something squared minus some number times that same whatever it was in here, but this time it's not squared, it's to the first power, and then plus or minus a number. Well, let's see what we got here. Now it's x to the fourth, and our middle term is x squared. Could I rewrite x to the fourth as something squared? Well, that would be x squared squared. And then we have our minus 3, x squared to the first power, plus 2. So this is an equation of a quadratic type. We could think about it like this, or, back to the old way, set up an empty set of parentheses here. What times itself is x to the fourth? Well, that would be this x squared. X squared times x squared. Our factors of 2 that add up to negative 3 would be 2 and 1, and they would both be minuses. And let's see, can we go any farther? Yes, again, we have two terms, multiplied set equal to 0. So I will set this term equal to 0 first. X squared minus 1 equals 0, and we could add 1 to both sides. X squared is 1. And then take the good old square root. X is, the square root of 1 would be our positive or negative 1. Now let's see here, our other term. X squared minus 2 equals 0. Add 2 to both sides. X squared equals positive 2. And then take the square root. X equal plus and minus the square root of 2. And since it is a fourth power equation, we do have 4 answers. Plus or minus 1. Plus or minus the square root of 2. Now these get a little tricky sometimes here. Equations involving radicals. Operations such as squaring each side of an equation, or raising each side of an equation to a rational power, and multiplying each side of an equation by a variable quantity can all introduce extraneous solutions. So when you use any of these operations, checking your solutions is crucial. So let's see what we got here. We have part A, square root of the quantity, 2x plus 7 minus x equals 2. And the strategy here is we want to isolate the radical on one side. So I want to get rid of this minus x. I'm going to move it over and make it a plus x. So on the left, I have my root of 2x plus 7. And now that's equal to x plus 2. And to get rid of the radical, we'll square both sides. So this quantity will be squared. And don't forget, this is a quantity squared. Don't just write x squared plus 4. That is a quantity to be squared that we're going to have to FOIL out. The left side's easy. The square and the square root will cancel, and we'll just be left with the 2x plus 7. And over here, we're just going to FOIL that out. x squared plus 4x plus 4. Now let's get everything on the same side. Since my x squared is positive here, I'm going to subtract 2x from the left, subtract 2x here, and I'm also going to subtract 7 from each side. And then we'll have a 0 on this side of equals. 0 equals, we have our x squared. 4x minus 2x is 2x. 4 minus 7 is negative 3. So we have x squared plus 2x minus 3, and that's equal to 0. And that does factor down just nice. X squared has to be x and x. Factors of negative 3 that add up to 2 would be a plus 3 and a minus 1. And then we set each of those independently equal to 0. Here, what would 0 that term out as a negative 3. And here would be a positive 1. And there's our two solutions. Now we're going to have to check these out and make sure they do work in the original equation. Because we did squared both sides there, and that has the possibility of introducing an extraneous solution. So if I plug in negative 3 for x, that's going to be 2 times negative 3 is negative 6 plus 7, and that's under the radical, and then I'm going to have minus x minus a negative 3. Does that equal 2? So under the radical we get a 1, and the square root of 1 is 1. Minus a negative 3 is plus a 3. Does that equal 2? Nope. That is a bad solution, or extraneous solution. And now we'll check out the easier answer. X is 1. If I plug in a 1 for x, 2 times 1 is 2, plus 7, minus x again is 1. Does that equal 2? So here we have a radical with a 9 under it. That is square root of 9 is 3. 3 minus 1, does that equal 2? Of course it does. Check. So this is our good solution. Alright, the first one, that was a relatively simple one because we only had one radical involved. Here we have two radicals, and it wouldn't be bad. We could just get one on each side of the equal side and then square both sides. But what really is going to throw a monkey wrench in it here is this lone 1 on this side. So this is we're going to have to do the previous process actually twice. So I'm going to take this term here that's minus on the left side, I'm going to add that to both sides. So on the left is radical 2x minus 5, and that's going to equal 1 plus the root of x minus 3. Okay, and here's where this starts to get a little tricky. We are going to again square both sides. The left side will be relatively simple. The square and the square root cancel, and we are left with what is under it, 2x minus 5. Now we have equals this, and we got to FOIL it out. So first times first will be 1, and then we'll have our outers and our inners will be 1 times the square root of x minus 3. So we're going to have 2 square roots of x minus 3. And then our last term times our last term will be this root times itself, which is just going to be plus x minus 3. Okay, let's see what we can combine on the left side there. We have our 2x minus, or on the right side, 2x minus 5 is still on the left. We're going to have, let's put our x term first, x, and then we're going to have our 1 minus 3 is minus 2, and then our plus 2 times the radical. Okay, so we went from having 2 radicals in the original equation, now we're down to 1 radical. So let's get this radical all by its lonesome, and then we can do the process again. So we're going to subtract this x out of here, subtract x. We're going to add 2 to both sides, going to add a 2 here, and then that'll give us here on the left x minus 3 equals 2 times the root of x minus 3. Okay, now right here you might be thinking, okay, I'll divide both sides by 2. Well, then we'd have, at least a fraction, or you'd have a half x minus 3 halves, and I'd rather not have to deal with those fractions like that. So an easier way to do it is, we don't have to have the radical completely isolated. We can square both sides right now, and it'll make it a little bit less work. So we're going to square this side, and then we're going to square this side. So foiling out the left side, we're going to have an x squared minus 6x plus 9. And then equals, don't forget we're going to distribute this squared. 2 squared is 4, and then we're going to have the square and the square root cancel, which is going to leave us an x minus 3. Alright, we're getting close. Let's distribute the 4 and collect like terms on the left-hand side. So over here, we're going to have a 4x minus 12. And I want to set this over here, at all equal to 0. So I'm going to subtract 4x, and add 12 to both sides. Add 12. So when we add these together here on the left, we're going to have, x squared minus 10x plus 21 is equal to 0. And then that left side is factorable. The two factors, of course, we're going to have x and x. The factors of positive 21 that subtract or add up to minus 10. That's going to be a minus 7 and a minus 3. And now we set each of those factors independently equal to 0. Independently equal to 0. So here, x minus 7 equals 0 means x is going to equal positive 7. And here, x minus 3 equals 0 will mean x equals positive 3. So we have our two answers, two possible answers, 3 and 7. Let's go back to the original equation and see if they in fact work. So here under the first radical, let's check this 3 first. 2 times 3 is 6, and we're going to have a minus 5 minus root of x is 3, so that's a 3 minus 3. Does that in fact equal 1? 6 minus 5 is 1, and then we have our 3 minus 3 is 0. The square root of 1 is 1. 1 minus 0 does not equal 0, so that is a bad solution, extraneous. We created it when we squared both sides, one of the two times we did square both sides. So hopefully 7 works out. Under the radical, 2 times 7 will be 14 minus 5, and then we're going to have a minus. Under the radical, we're going to have a 7 minus 3. Does that equal 1? Well, the first radical, 14 minus 5 is 9. 7 minus 3 under the second radical is 4. Does that equal 1? Square root of 9 is 3. Square root of 4 is 2. Is 3 minus 2 equal to 1? You bet it is. So that is our good answer. X equals 7. So let's see. That was quite a bit to digest. Got a couple practice problems here, and these mirror pretty much the examples we just did. Let's see here. Yeah, the first one, just factor and set each factor to 0. The next one looks like it's going to be, well, I'll let you figure it out. We have one of the quadratic type, and then one of the simpler ones to get rid of the radical. So give those a try, and start the video back up and see if you got them right. Okay, let's see. In the first one, let's see, what should we do first? Remember, we don't want to divide through by a variable quantity, but we could divide through by a 2, just to make our numbers a little easier to work with. So that would be a 3x to the 4th minus 7x squared equal to 0. And now the numbers we can't factor anything out of, but we could factor out an x squared. X squared times 3x squared minus 7, and that's equal to 0. And now we can set each factor to 0. Here, x squared equals 0 means x is going to equal 0. Here, we're going to have 3x squared minus 7 equals 0. So we'll add 7 to both sides and get 3x squared equals 7. And then divide by 3, x squared equals 7/3. And then we'll square root. So we'll have our x equals plus or minus the root of 7/3. And that's the first one, number 5. The next one, we have a 4 term. Highest power is x to the 3rd. So that is a dead giveaway that your first shot should be at factor by grouping. Pull out an x squared, and here's going to be an x plus 2. The next term, factor out a 3, and we have the same x plus 2, so we're looking good so far. And imagine there's a big set of brackets around here. If we factor out the x plus 2, what's left in the brackets is x squared plus 3. And these are equal to 0. Set the first one equal to 0. X plus 2 equals 0 means x has to equal negative 2. And here we're going to subtract 3 from both sides. X squared will equal negative 3. And then do the square roots. So we're going to have x equals plus plus or minus square root of negative 3, pull out the negative as an imaginary, and we'll have our radical 3. And this last one is a quadratic type. So our first power is, x to the 4th, and then we have x squared. So it's just a different looking type of problem that we've been factoring for quite a while now. How would you get x to the 4th? Well, that would be x squared times itself. And then what are the factors of negative 36 that add up to positive 5? That would have to be 9 and 4, and let's see, it'd be a positive 9 and a negative 4 to get our positive 5 in the middle. And now we have these terms, and set each one equal to 0. X squared plus 9 equals 0. Means x squared will equal negative 9, and then we square root. So x will equal plus or minus, the square root of 9 is 3, and the negative will come out as an imaginary. And here on the other side we have x squared minus 4 is equal to 0. We add 4 to both sides, x squared equals 4, and then we square root. So x will equal plus or minus 2. Alrighty, fourth power equation, 4 answers. Plus or minus 3i, plus or minus 2. Oops. And let's see. What do we got last here? One of these ones with a square root in it. So it's only got 1 in it, so it won't be too bad. Let's get that negative 4 to the other side where it will become a positive 4. So we're going to have, oh yeah, this one won't be bad at all. So we have the radical isolated, the 4 is on the other side, and now we square both sides. And this will be nice because over here it's just a 4 squared. We don't have to FOIL anything out. So the radical and the exponent here will cancel, and we'll have x minus 10 is equal to 16. And we'll add 10 to both sides and get x equals 26. That wasn't bad at all. The assignment for this section, 1-6 day 1, that's on page 137 of your book. And here are the problems. Pay special attention to the even ones.